Okay, I think we're going. Okay, it's live. Hey, y'all. I'm Karl Schelhammer. I'm going to be talking to you guys about improving ROI with ML ops. This is a topic near and dear to me. I've kind of lived both sides of the data science, kind of good pattern, bad pattern. So I'm going to be taking you through a story of just kind of the way that I think about this. And yeah, let's go from there. So let me just make sure I've got my thing pulled up here. 1 second. Okay, so over the last couple of years, we've seen lots of advances in data science, AI, and ML. There's a huge landscape of vendors to provide prepackaged services that address issues with capabilities in the ML pipeline. And these services proliferate, and as a result, the number of data science projects that data scientists can deliver is going up because of the way that models have been wrapped up into services, the way that some of the heavy lifting around architecture has been solved for, and data science role now is sort of in flux. It's shifting. It's not just the modeling and the data prep and everything we have to know about the models and bias and all of that sort of stuff. Now it's also the technology and the means of deploying that in the wild. And so recently similar advances have been made in the software engineering and data engineering space, namely in DevOps. And I'm sure everybody's heard of that before. So I'm going to be talking about ML ops, which is sort of a take of that. It borrows a lot of those ideas and principles, but the way that we apply them to ML is a little bit different, and we focus on a little bit differently, and we care about different things. But I think we'll establish what the benefits are, and I just want to lay out 3 key questions here. So we're going to be trying to look at first of all, why do we even need this? Why do projects typically fail? And then a little bit about the model lifecycle and how that kind of drives performance. And then, what are the things that practitioners or executives should start focusing on skills-wise to get there? Okay, so why worry about it? So this is a story that kind of comes from my personal experience. This is an operating model that I've lived more than once, and I call it the throw it over the wall model. And basically what you have here are 3 kind of key groups involved in the data science process. So, in the upper left, naturally you have the data scientists, and they interact with 2 other groups. And one of the groups are the stakeholders at the bottom of this unstable pyramid. And, they're the business users. They work the business functions. They may be in marketing or sales or procurement, and they need the data science team to do something for them, model something or provide a capability. And they make that request, and the data science team, typically has or historically has a skill set around modeling and data munging and all of these things. But, maybe they don't have all of the know-how or the means of actually putting those insights to work in the wild. And so we work closely with our operations team, who's removed from the data science team. They don't participate in the POC necessarily, oftentimes is the case in my experience. And what happens is once the data science team has built out an MVP, they did their POC, they figured out how to do it, they built, the bare bones of it to figure out, how do we deliver this capability? And it goes to operations, who has a different set of responsibilities. They typically are the people that keep the lights on. They maintain, all of the systems and the networking. They build APIs. They may do custom development to provide capabilities within the business. And, in this model, what happens is we hand off the data science model to the operations team, who re-implement it in their own ecosystem, maybe even using their own language and or a different language or different libraries. And that's the way it's done. And there's some issues with that, and I'll get into that in just a second. And these stakeholders now they have a situation where they're sort of in the middle. They're on the wall. The data scientist team and the operations team are on opposite sides of the wall, and so you can kind of start to see what's going to happen next. So I'm not going to totally throw this under the bus. And if you're living this or you have lived it, no worries. I mean, this comes from a good place, right? Because it's hard, I think it's hard to get everybody kind of on the same page here. And I'll get into that later. But it does kind of consolidate the skill set. So the data science team can focus only on the data science side of it. Operations can focus on their core skill set. But there's also some risks, because what happens when something goes wrong? Because now what we've done is we basically decoupled the data science team who developed a capability from the operations team that provides the capability. And there's naturally a disconnect there. No matter how hard you try to mend that, there's two groups, there's two entities. And it's complex. It's complex for the stakeholders to know what happens. Let's say an API goes down or it starts giving a result that looks wrong. Well, did the data science team not really think of that edge case, or did maybe they munch something up in the implementation of it? So there's something lost in translation here when you throw code over the wall and you give something to someone else. And documentation and things of that nature kind of ameliorate that a bit, but that's itself an imperfect means of communicating between individuals or groups. And the result of all of this shuffle is slower time to value. And that's kind of what I mean by ROI, right? We all know that data science projects are hard to deliver on. And one of the reasons is because of this. They get lost in this shuffle, and depending on how this goes, it may not be worth the effort. So let's talk about an alternative to that. And so modern model management, what is the way to do this? And basically, companies are starting to approach this and where to start, right? Because this is kind of intimidating, because we're talking about, organizational change as well as the kind of techniques that we need to be able to do this. And I think the first thing is to lay out a clear vision, set your North Star, articulate the way that you want your teams to work in the future. So, individual needs may vary depending on your particular pain points, but I think that vision ought to include at least these key elements. And I'll sort of go down the list and say why I think they're important. So number one is API endpoints. So API is sort of like the language of technology nowadays. And, in the olden days, maybe we would do our projects and land a CSV or a flat file. And then, we'd go and email it off to a group, and, somebody gets left off the email, or, oh, wait, well, we wanted you to do it this way or for this set of dates. And then now you redo it and, you've got multiple emails. It's hard to track. Well, API endpoints allow us to deliver data science insights as self-service. So if a stakeholder wants to run your model, or they want to, deliver inference off of it or something like that, they can, form an API request and then send that into your service, and it just returns the answer. And part and parcel of that is, managing that kind of technology, because that can be a big shift and it can be intimidating for some organizations. And so, the second thing I think that needs to be a part of that vision is CI/CD, which is continuous integration, continuous deployment. And this is a mode of being that's been in the DevOps community for a while, and it's basically scripting and kind of programming the tools that we need day to day, like GitHub, like the cloud, to integrate seamlessly, so that when we do updates to our code and we push and we test and we vet, we can automatically deploy to our environments, because we have declarative infrastructure as code, because we have thought through the kind of steps that need to take place with the data and the model prior to that. So that's a big part of, I think, managing APIs as well. And next, monitoring. So, okay, now we're a successful data science team and we've got all these APIs serving results in prod, right? How do we actually keep track of all that? And, do we have a model version to roll back on if something goes horribly wrong? And, the world isn't static, things move on. How do we keep up to the pace of now with our model training and tuning? So these models have a life cycle of their own. I was going to say something about COVID-19 here and behaviors, but I think we all get it. Run a little slow on time. So this is what I think a good model looks like. So now we're all in the circle. And so, I could have left the stakeholders out of this, but we'll just leave them in so they don't feel bad. And so now we have the data scientists and an ML ops engineer working closely. And the way that it's drawn here, it's different individuals. And, depending on the needs of the team, it could be, it could be a multitude of things. Maybe you have an ML ops specialist supporting a team of data scientists that gets both sides, that can, respond to modeling changes and knows how to monitor and read objective functions and actually build the means of monitoring and automating that in a way that serves the need of the data scientists and the business. So now we're working together. Or it can even be, maybe if some of these data scientists all have a little bit of the ML ops skills, and so they're all kind of self-sufficient in that regard, and they all can kind of work in that way. And there's substantial benefit to this because now modern delivery techniques, right? You're doing it in a way that you can integrate with other business functions. You can drive applications. You can provide those sort of self-service insights. You've got automation around your model update process. So when somebody wants seemingly small changes, we're not fumbling through massive amounts of code to make that happen. Everybody's been there before. So no more fire drills. And then, keeping tabs on things, monitoring and dashboards allow us to have very, up-to-date insights on when things go wrong and be proactive about responding to failures. And all of this is so that we can rapidly deliver on the promise of value, to get rid of all that shuffle so that we have the right people with the right skills to just deliver on the thing that we're good at. And it's not without risk because, some of these ways of thinking through ML ops, it takes some new skills. Maybe you've never seen a CloudFormation template before. Maybe you've never done a SageMaker hyperparameter tuning job. Those are definitely things that need to be tended to. And I think as part of that executive vision for the way data scientist teams need to work, we should be encouraging our people to go and learn those things. And also this works best in the context of a culture of DevOps. So when you have other business units sort of thinking this way, right? Delivering an API into a vacuum where nobody can really use it doesn't work. So, we do need to be cautious about that and think through the organization as a whole. But I think that means that this is this is an element when, as organizations think about modernizing in general, to keep in mind. It's an important part of the puzzle. And moving right along, now I'm going to talk about a little bit more about the key characteristics. And basically, this kind of aligns on the principles behind what ought to drive that vision and the way people ought to think about their own skills. Because we talk about automation and scale, right? Environments are constantly changing, like volatile, some of them in very volatile ways, like with the stock market of a heavily traded company. And some environments change seasonally, fashion, retail, traditional industries, or it can change all at once, like we mentioned with COVID. So like we really need to think through the strategies that we have for dealing with automation. And, let's say, do our models need to be updated every month? Do we deliver on a monthly cadence, or, does our industry potentially move faster than that? And then maybe we need to build in KPIs and think through, reacting dynamically to, degradations in service and triggering our pipelines that way. Standardization and alignment, right? So the workflow. So is it a repeatable process? Do we use patterns that translate across an industry? Making sure that the businesses buy in. So like, that stakeholder relationship and the trust that you have, being able to deliver reliably is a big part of that. And, all of that is a means of reducing risk. And, lastly, I talked about this a little bit before, but like, integrating into production systems, right? For some of us, having a data science model out there, driving a customer-facing application is scary. But when you begin with that end in mind, you integrate all of these components, you can do that because there's no questions. You can manage your models, you can update, you can track their performance in time, and you know what it's doing, what's happening. So here's just an example of what a possible pipeline might look like, right? So, I mean, this is sort of a boilerplate diagram here, but on the left, we have data sources, and then we do some things to get our model into production. And, this might involve some kind of data ingestion or preparation, analysis, ETL. And then the rest of this is sort of like a feedback loop. So we do our development, we train, we build, we validate. Model registry is something I'm going to touch on lightly, but basically, how do we actually maintain older versions of this so that we can kind of compare and contrast and look at what's going on, through time. and deployment. So this goes back to kind of the pipelines and whatnot we talked about before, inference, connecting to APIs, being able to drive it, and then this feedback loop. So what's going to happen when reality drifts or bias becomes an issue suddenly? Like, do we have the cycle that triggers this loop so that we're constantly reacting proactively to what's going on in the world? And I'm kind of going through this quickly now because I'm about out of time. But I hope the takeaway to this is really getting people thinking about where do you want to be down the road. I mean, this operational ML is a big picture. It's a big thing to do, but fortunately, all of the components in and of themselves add value. It's not an all or nothing approach. I think, depending on your needs, you can start with any one of those elements that were laid out previously, and you can start to modernize your approach to this very cool space. And the benefits outweigh the cost. It takes a little work to get there, but you can go one step at a time. You can think in terms of your organizational maturity and progress from there. So I did leave out some things. I didn't talk about feature stores or data governance or A/B testing, or I didn't really get into anomaly detection. So there's more to MLOps than I laid out here. But anyway, just kind of wanted to set the stage and talk about some of the good and some of the bad. And yeah, I'm Karl, and I might get the hook here in a second, but I've been doing this for a little over a decade. I've built these the wrong way and the right way. I would love to talk to you or your organization about this. Be happy to come in and kind of share our vision or talk about what we can do. And yeah, check us out. Check out Slalom. If you're interested, check out our review on AI for All, Tuesday, October 26th. And I'll leave it at that. Do we have any questions? I don't even know where I would see that. Can we get the slides? I'll see if I can share them. If I can, I can socialize that with you, Paige. All right. No other questions? Going once? Going twice? All right. Well, I hope you guys have a great day, and we'll talk to you later.